And welcome, space weather enthusiasts, to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name and news. And we've got an Earth-facing quiet, which is about to expire. And what that ultimately means is that the likelihood of large solar flares is rapidly rising up here in the Northwest. So this sunspot group right over here, it is becoming more and more likely to produce a large solar flare. And while we don't have a whole lot of sunspot growth or anything like that, there is one new group that formed down here in the southeast. So right there you'll see a new sunspot form. Right in this area. Right there. So that is one new sunspot. And the major story is filaments. Still, it's filaments. So we do have a massive CME outflow sort of event, a low-speed event going on right now. It's not earthly directed. But I would draw your attention to all of those plasma filaments. These are all 24-hour videos from SDO, by the way. This is ionized helium and ionized iron. You can see a crown prominence up there, another solar polar vortex forming, this time around the north polar region. Another huge prominence here at the northwest. So also a great view of that sunspot there. Again, the Earth-facing quiet is expiring as that approaches the limb, increasing the likelihood of it producing large solar flares. Here's your equatorial view in those same wavelengths. And here is the southern hemisphere. Check out the huge filaments there to the east of the Earth scale. That is one giant filament indeed. And filaments are known to become coronal mass ejections, so we cover them on the regs on the channel. So that's what's going on in a nutshell. Let's take a look at sunspots here briefly. We'll show you a little bit more imagery there a little bit later in the video. Again, one new group formed down here. It looks like it's only an alpha class sunspot at the moment. Only one polarity umbra there. There is the colorized magnetogram. That's yesterday plus today, by the way. These browse data features show full days, so that is September 6th through September 7th to date. Let's see what's erupting as far as volcanoes. Fukutoku Okanoba, an underwater volcano, has been producing some floating pumice. So there's a warning area there in the ocean near the volcano islands of Japan. Fukutoku Okanoba now erupting. Uluwun also erupting there. New Britain, Papua New Guinea, it's exploding. It's producing a 9,000-foot plume of volcanic ash. Also Semeru on East Java, Indonesia, producing a 16,000-foot ash plume as it explodes. It's a flight level 160, flight level 1310 over Shishaldin, a 31,000-foot ash plume. There, once again, the most active volcano in the world is in the Aleutian Islands as Shishaldin explodes. Flight level 310 over Shishaldin. Flight level 200 over Popocatépetl in central Mexico. Fuego in Guatemala exploding. Flight level 140. 15,000-foot ash plume over Revenador. Flight level 150. Not sure about Sabancaya. Don't pole vault the caldera. We have had one major earthquake over the past 24 hours. It was a 6.2 at Chile there the past 90 days. And there is that 6.2 there just off the coast of Chile there, south of Coquimbo and La Serena. So that's the location of that 6.2 magnitude quake. We'll cite all the quakes over 5 or greater magnitude for the past 24 hours. So let's see here. What do we have? It looks like Tonga. Tonga had a 5.1. That was at 17:03 Universal Time yesterday afternoon. And there's that 6.2. That was 12 minutes to midnight at 23:48 Universal Time yesterday on September 6th. Also some quakes there at the Pacific Antarctic Ridge, where the Pacific Plate meets the Antarctic Plate, hence the term Pacific Antarctic Ridge. So a 5.1 and a 5.2, only about 11 minutes later at 5:01 Universal Time, and it's time to get back to space. So yeah, space, a frontier. These are the voyages of this channel. Another 24-hour video there. That's SDO 171 angstroms. We'll also show ionized helium 304 angstroms from SDO, the Solar Dynamics Observatory. Again, check out the filaments. Those are some serious filaments. Filaments all over the solar disk. Next, the 10.7 centimeter radio flux is currently at 147 solar flux units, a small uptick from yesterday. And there is the 1 year chart. So a significant uptick in the past 2 days. Now looking like it might be leveling off. No major new sunspot activity there. 147 is the new number for the 10.7 centimeter radio flux. Sunspot number here at 131. And we do expect that to rise to at least 137 today with that new Alpha class sunspot. As far as space weather events here in the forecast, no space weather events there at all. No significant upticks there, and the solar wind is expected via coronal hole high-speed streams or coronal mass ejection impacts. NOAA forecasting calm conditions for space weather for the coming 3 days. Next, Earth's magnetic moment from space. We show it daily on the channel. You never know when the data will become relevant. At the moment here, for the past 4 hours, it looks like the pressure is on the magnetotail side of the planet, which, by the way, does not prove that there's a spooky, invisible planet like Nibiru in the solar system. Here are the past 4 hours of Earth's magnetic moment from the ground. And again, we're in a geomagnetically calm state right now, so you're not going to see too much as far as ground magnetic perturbations here. This depicts changes to Earth's B field in nanotesla, the units of magnetic flux density. So that's a great animation there of Earth's magnetic field. And here is the planetary K-index, currently at 1.33. Again, it is geomagnetically calm here and no space weather in the forecast. Now, we did see some activity yesterday. It was right around when we forecasted a possible glancing blow CME impact. And indeed, there was a signal there. So we saw a downtick in the plasma temperature, an uptick in the solar wind density, and a change to the magnetic fields there. So that does look like a glancing blow CME impact, a very minor one, barely even showing up there as a signal. And I'm just going to press refresh here. The most current conditions we have here are just under 5 protons per cubic centimeter for the solar wind density. Solar wind speed here, 372 kilometers a second. GOES magnetometers. Those are, by the way, geosynchronous near equatorial satellites. And they are showing a little bit lower highs and indeed lower lows here over the past 24 hours. But it's a fairly normal range there for the GOES 16 and the GOES 18's magnetometers. So nothing too special happening there. Earth is in a South Pole-oriented current sheet depicted here in red. The heliospheric current sheet is polar, the plasma. And there you go. South Pole current sheet depicted in red. It's a long way for the next sector boundary crossing. Just keep in mind the magnetic environment can suddenly change with basically no warning. So here is the solar B field depicted in blue. That is our line of sight field plot. This magnet being the sun, and let's move to coronal holes. arguably the most important feature of a solar cycle. I know some people would say sunspots. Perhaps you'd say solar flares or coronal mass ejections or plasma filaments. All these things are important features, but the coronal holes show us the magnetic field reversal process. As south becomes north and north becomes south, that is a solar cycle. We've got south pole oriented coronal holes here at the moment, so lots of south pole coronal holes here rotating in the east and the southeast. Let's take a look at those through SDO. There is the 24-hour video in 211 angstroms. And let's get to sunspots. So again, we have the Earth facing quiet is expiring up there in the northwestern limb. And by the way, there are some sound theories as to why this happens, or at least a hypothesis. So here's a sunspot situation. Again, no major changes here, no major evolution of sunspots, but one new one did form right down here. So we can expect the sunspot number to rise at least by 6 if there's only one umbra there. Due to the conventions for counting sunspots, I won't get into it at the moment, counting sunspots. But you can see quite a high likelihood of large flares here. Let me just stop that at the most recent frame. 65% chance there. So, just like I said, this sunspot here, 3241, very likely to produce M or even X-class flares. Look at that, an X-class flare more likely than an M-class flare. 55%, indicating significant magnetic shear. It is a beta gamma delta class sunspot. So here is the past 24 hours. We're showing the SDO continuum here with 131 angstrom superimposed. And so we've got two significantly complex sunspot groups there in the northern hemisphere. The one on the western side, a little bit more complex. And let's show the magnetic fields. That's the SDO magnetogram for the last 24 hours. So the glory of doing daily space weather videos is that we're showing typically 24-hour spans. It's a great amount of solar data there to consume at a time. And there is indeed some evolution of that sunspot, which you can see on that magnetogram. And let's talk solar flares next. And we have actually seen the background level of flaring rise here a bit. So, first energetic particles, as in SEPs, and the Gauss proton flux here is mostly flatlined there. There was a minor event that happened right around midnight on September 6th, really on September 5th, and that did create a minor solar energetic particle event, but it is near baseline, so not likely to be causing any polar radio blackouts or anything like that. Now, part of the theory, a plausible theory for the Earth facing quiet, is 40 lines of evidence for condensed matter, the sun on trial, liquid metallic hydrogen as a solar building block. Did you know this paper becomes 10 years old on October 1st? Yeah, it's pretty controversial, by the way, as if this is the correct model of what the sun is made of, it forces a rewrite of cosmology. Yeah, it's pretty serious. And by the way, the paper that I'm writing, which explains the solar sunspot cycles, would likely not have been possible without this one. So if you haven't read it, check it out. You can find it all over the internet. It's very easy to find. Again, the title is 40 Lines of Evidence for Condensed Matter, the Sun on Trial, Liquid Metallic Hydrogen as a Solar Building Block by Dr. Pierre-Marie Robitaille at the time of the Ohio State University He was in the Department of Radiology. He was actually the chair of the Department of Radiology. And if you want it in more layman's terms, because you don't want to read a science paper, well, check out our Amazon store. You can find Alexander Unziger's recent publication there, The Liquid Sun, A Coming Revolution in Astrophysics. So astrophysics, cosmology, heliophysics, and even things like geology will be affected. It's pretty serious. The paper turns 10 years old on October 1st. Highly recommend that you read it. Some of us believe that it is part of the reason for the Earth facing quiet, also likely explaining why sunspots are dark because they're flat, and all kinds of other interesting ramifications. Like also, by the way, stars are probably a lot more stable than is commonly believed. I'll just leave it there. Facts from the Smash News Network, least busted name in news. And the X-ray flux has come up a little bit. We're right around a C-class background X-ray flux now. So a C1 background X-ray flux and a very high likelihood of major solar flares. That's the past 3 days from the GOES. And next is where we goes. We goes to our custom 24-hour SDO video. That's 131 plus 94 angstroms. So that major sunspot there, right above our Earth scale at the end of that video, that is the place for a major solar flare watch. We'll show you high-res imagery of it when we close out our space weather section and move to meteorology, and show you things like the Atlantic hurricane forecast. So make sure you stay tuned for that. And let's move to a star chart. So for some people, this is part of space weather, right? They want to know what's going on overhead. Try skyandtelescope.org if you want to build a star chart just like ours. The sun not peeking over the horizon yet here. However, we do have a last quarter moon there. Also Jupiter up there high on the ecliptic. And if you're viewing the evening sky, you might be able to see Mercury if you've got low light pollution, a low horizon, and clear skies. Here's your solar system forecast. And let's pause for station identification. You've reached the Smash News Network, least busted name in news. Here's where things are today. Let's advance this 1 week. And we're about 8 days out from the new moon, which will be on September 15th, it looks like, from that imagery. That's your 1 week forecast for the solar system. And let's take a look at the astronomy picture of the day. Oh, it's a good one, too. Yeah, the astronomy photo of the day at apod.nasa.gov. This one is the Large Magellanic Cloud, which contains not only the closest supernova of the modern era, supernova 1987A, it also contains the Tarantula Nebula. I believe we're looking at ionized hydrogen and ionized oxygen here on this imagery. The Large Magellanic Cloud, the satellite galaxy of the Milky Way. It's located about 150,000 light years away. There's the full view of that. The Large Magellanic Cloud. That makes a great desktop, by the way. Check out the resolution of this thing. If you've got certain features that are your favorite, that would even make a great background for our star field. And once again, you can find it at apod.nasa.gov. There you go. Moving right along to coronal mass ejections. And there are yesterday's images. That's 106 frames from yesterday. It was pretty calm there. Kind of a shortage of CMEs here in the past couple of weeks. We'll also show today's frames. There are an additional 41 frames, and like I said, there's a huge outflow coming out of the northeast. That is not likely to have any earthly directed components there. but a massive low-speed coronal mass ejection and outflow. Great imagery of that. Here we've got C2 and C3. And whoops, there goes a bunch of plasma. Here's a little closer view. Let's just advance this. Here's the latest from the C3. A very bubble-like CME there with a denser core. Great visual there from the LASCO coronagraphs. We would also show you stereo A, but unfortunately the data is outdated. So the latest data there is only from yesterday morning. We'll just skip that entirely. Stereo A there showing outdated data. And before we show the filament situation, let's take a look at CMEs here on our custom 24-hour videos. So not a lot happening until just this morning there. That massive CME there popping off on the northeastern limb. I think it's slightly behind the northeastern limb. Very unlikely to have any earthly directed components. Here's a little closer view. A little bit of a gap in the data there, unfortunately. And there's an even closer view. So you don't really see any motions on the Earth-facing portion of the solar disk. Probably an indication that there is another active region or two behind the northeastern limb. So we've got magnetic fields suspending that plasma, and then magnetic fields changing and causing that plasma to probably partially splash back down and partially eject into space. That is what's going on. And here are filaments. So this is the El Teide, Spain ground-based solar observatory, and check out the size of that filament in the southern hemisphere near the South Polar region. That is a major filament. That one's worthy of a name, by the way. So we'll talk about naming filaments here in a minute. First, the El Teide hydrogen alpha, zoomed out there in grayscale to show prominences when filaments hang off the edge, and we've got multiple prominences. That filament down there is certainly a beastly filament. In fact, that's one of the largest and densest ones we've ever covered on the channel. Over 6.5 years, practically. So if you want to name filaments, join us over on Twitter. Just follow the hashtag #NameThatFilament. And this filament down here is the one we're talking about. So perhaps name that one. Name them after living people, because filaments are dynamic and often lively. So sort of in the spirit of naming, now people are naming winter storms. I mean, tropical depressions are getting names and everything's getting names. So hey, space weather, we're taking it mainstream. Shout out to Tamitha Scove. Space weather, it's becoming mainstream. It's becoming more and more important with things like private space flight. So name filaments after living people. Who do you think we should name this filament after? If you've got ideas, go join us over on Twitter. That's the place to name filaments. Certainly not in the YouTube comments. Anyway, here are the past couple of hours. Again, a very high likelihood of solar flares, including indeed X-class solar flares, especially in the northern hemisphere and especially in the northwest. So these are basic facts, and folks, solar flares can indeed be forecasted. It's just a matter of understanding the magnetic shear. If you look at close-up magnetograms, which we'll show you here before we close out our space weather video, you too can forecast solar flares. This has been well known for at least 20 years, I want to say. Next bonus features, charging hazards. We don't have any. It is smooth sailing there, no surface or internal charging for satellites. The GOES electron flux here a little bit lower than yesterday. Let us know in the comments if you think it'll get into warning territory today. I don't think so. I think it's dropping down. There is the 1-year graph to put it in context a little bit for you there from Solon.info. And here is the forecast model. NOAA is expecting flat or slightly reduced levels over the next 2 updates. The green boxes are the forecast there. The yellow diamonds are the observation. We'll show the layer where the electron flux is measured, the F layer of the ionosphere. And by the way, if you want to read more about the ionosphere, first theorized back in 1839, in many ways a golden age of science. There's a great wiki article there. And of course, Marconi completing the first transatlantic radio signal. And there's all kinds of information about the South Atlantic anomaly and so forth, and high altitude lightning and things. Anyway, this is the F layer of the ionosphere, courtesy of Australian Government Bureau Meteorology. If that's Greek to you, don't worry. Here is the anomalygram. So things pretty normal there in the ionosphere. Nothing really too exciting happening, at least that we can tell. There's a latest image, 10:15 universal time for the ionogram and 10:15 universal time for the anomalygram. Next, total electron content. This is always relevant to humans as it'll show the most likely place for GPS errors. Your GPS satellite's at like 12,500 miles of altitude. These are the free electrons between it and your GPS handset. Things are quite organized here, so free electrons not really out of place. The most likely place for GPS errors is, of course, around the equator at noon, and again, things are quite organized. So no major anomalies showing up there, at least on the global map. Let's show a little more local map for our North American viewers. There's a total electron content anomaly from the 10-day average over North America. We are seeing significant high electron counts here over, once again, northern Canada. Also this time adding Mexico. And portions of the west coast of North America, places like around Vancouver, British Columbia, and the Cascadia Fault Zone. We'll play it through one more time, and then we'll show you those high-res images we promised of the closest star. Oh, and by the way, if you're not familiar with our mission, you can check it out at smashomash.com/forum/mission. And part of the reason why we immerse ourselves in the data in science is because you never know when you'll end up with answers to questions not asked, which is what happened to me. That is why I'm composing a paper explaining the solar sunspot cycles. It's pretty berserk. But anyway, here's the latest image. Here's a sunspot to keep your eye on. And when I say eye on, well, dag. Pun intentional. That is a major sunspot. It is beta gamma delta class, the most likely type of sunspot to produce large solar flares. And we'll also take a look at this sunspot over here, the second most likely place to see a large flare. Also beta gamma delta class. So that's what's going on. And let's move on to earthly weather. Before we do that, take a moment to press like. If you're new to the channel, press that subscribe button. Do yourself a favor and get the world's most comprehensive daily space weather content here from the Smash News Network, least busted name in news. And please don't suck at math. Just kidding, folks. You can suck at math. We're not sticklers for that kind of stuff. However, feel free to use our equation here when you're arguing with all the herp-derps on the internet about things like space weather, heliophysics, astrophysics, cosmology, etc. Maybe geophysics. Just saying. Do the math. 8 == capital D. Try not to suck at it. Hopefully the content you're watching on YouTube doesn't suck volleyballs through drinking straws. So it also features an extremely high-resolution image from SDO in our house favorite wavelength, 171 angstroms. Yeah, do the math. We showed our work. 8 equals capital D. You can find links to that. Also, it does have our URL there, snuck into the bottom of the sun at the South Polar region right there. Smashomash.com invites you to do the math. You can find links to our Redbubble shop on the homepage. And by the way, save 40% site-wide at the Redbubble shop by entering the promo code You Deserve It. You deserve to click our links. Smashomash.com is our homepage. We launched it in 2019. So check out our links there. You can find us on Instagram, Twitter. There is a Facebook group called Entropy Busters. Yeah, because misinformation and disinformation is indeed entropy. You can also find links to the Hemp Lucid shop down there, so check out those products. If you're in the market for CBDs, buy them through our shop. Help support the channel and increase the probability these videos will continue to exist, remain publicly visible, and free for all to view. Thanks to everybody who picked up product, whether you did it from the Amazon shop by picking up Unziker's book, The Liquid Sun, or by picking up CBDs, the most popular of which are the water-soluble CBD tinctures. So perhaps those will be helpful for you if you haven't tried them out. Links below the video and on the homepage at smashomash.com. If you want to support the channel via subscription services, consider becoming a member of the Smash team. Why? Because in 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. No, you certainly can, because there's a website. Join at the gold level, the silver level, or even the bronze level. Get email alerts about videos just like this one, and improve your understanding of the weather all the way from the sun all the way down to planet Earth. Speaking of down to planet Earth, look at all the hot water in the Western Atlantic. That water right there where the green circle is, that is 86.3 degrees. That is pretty hot water indeed. And this system is going to be moving right toward it as it continues to intensify. So becoming a major hurricane as we speak. That is the sea surface temperature scenario for the Western Atlantic. Quite a lot of water there that is at high temperature, which will aid in the strengthening of that system. So here is the wind situation around the planet. We're going to show wind and jet streams. So there are the surface winds of the east. There are the jet streams of the east. Here are the jet streams of the central world. Here are the surface winds of the central world. Surface winds of the west. They're going to be picking up in the West Atlantic. And these are the jet streams of this side of Earth. Doubled up jet stream there over North America and a divergence over the Western Atlantic. So let's do a forecast here. We're going to just move this ahead 3 days. That is Sunday at 12 o'clock Universal Time. A second system here forming as well. But the one to really pay attention to is this one. That's the GFS forecast. And there's the Euro forecast. Euro forecast there predicting higher winds. GFS forecast predicting a little bit farther north. So again, there's the GFS, there's the Euro, GFS, and Euro. Moving right along to clouds and fog over the Americas. Again, as that system gets closer and closer to 86-degree water, it will strengthen. So here's the forecast from Tropical Tidbits. That's depicting mean sea level pressure as well as the wind at 10 meters. There, the pressure dropping all the way down to 941. That is the kind of pressure associated with a major hurricane. GFS 72-hour model there depicted. We show 3 days at a time because those forecasts tend to be accurate. Moving right along to our weather.gov map, we'll briefly scroll down to show you the key. There you go. There is weather.gov's map. Excessive heat warnings here as the heat wave continues in Lehigh Valley, Pennsylvania. Hottest temperatures in the country there are places like Arizona and Texas. Here's your smoke forecast. That is courtesy of firesmoke.ca. Ottawa, Canada there, expecting some thick smoke, as well as the northern Great Plains like North Dakota, South Dakota, Minnesota. Some significant smoke in the forecast there. And let's do our temperature anomaly forecasts. This is temperature anomaly in degrees Celsius. So that's the GFS 72-hour temperature anomaly forecast. Mostly hotter than average temperatures here across the U.S. Summer is ending with some heat waves. Next, your pressure and precipitation forecast for the same model and same period, the 72-hour GFS model. Some rain coming there to the northeast. Next, your jet stream forecast. And just a quick tidbit from Tropical Tidbits. Mankind, it's not from Tropical Tidbits, it's just from me. Mankind doesn't control the weather. The jet stream largely controls the weather. And, nobody's contesting weather modification. We're contesting things that aren't real, like chemtrails, or that HARP is weather modification. Yes, people think HARP is weather modification, folks. Anyway, that's your 72-hour GFS jet stream forecast depicting the 250 millibar winds, which are the jet streams, in effect. Anyway, next, your lightning mapper. That's where lightning's been striking. Pretty mild here. And at the moment, do we have any terrestrial strikes? Looks like some lightning here north of Pittsburgh there. Next time you hear thunder, check it out. lightningmaps.org, highly recommended. It could actually save your life, which means this video will probably be deboosted. So press the like button. Oh, geez, we hate to give out valid information, folks. It's very dangerous. 2023 featuring dangerous, spooky facts. Oh, my gosh. Pardon all the facts. Again, if you're new to the channel, press subscribe. Get the world's most comprehensive daily space weather show delivered right to your subscription feed. Or better yet, sign up at smashomash.com for email alerts and don't rely on notifications from certain tech organizations who will remain unnamed. We're going to close out the video with the latest Doppler, cloud cover, and water vapor. So first, Doppler. That is vertical motion in the air column. We're going to focus on the lower 48. There is clouds and fog, 3.9 micrometer infrared radiation. It shows clouds and fog even at nighttime, and there is water vapor. Huge mass of dry air here. Check it out. That is a high-pressure system. Big time. And, of course, dry air is more massive than moist air, so it has a tendency to push it around, which is exactly what's happening here, and creating some major pressure gradients there based on that low-level, weak relative low. It's enough to produce precipitation, as you can see there on the Doppler. Anyway, here's your recap. Doppler, clouds and fog, and there is water vapor, and that is where we will close things out. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back.